Hello. Hope everyone is starting to get back into the swing of things. I know this is a really strange year for all of us. So today we're going to be starting with our first kind of real notes for the year for geometry. So these are on segment addition and midpoint. So in terms of segment addition, we're talking about adding parts to equal a whole. When we're talking about midpoint, we're talking about dividing a segment right at its middle, so into two parts. So first let's label these. So 1.01 Geometry Honors notes, and they're going to be on segment addition and midpoint. So before we start doing the problems, let me just draw out what the difference between the two, segment addition and midpoint, is. So segment addition would be if I took this whole segment here from A to B to C, and I have it divided here at B. So segment addition is saying if I take AB and then I add it to the length of BC, that would give me the entire segment. So segment addition just means that the sum of the parts of the segment equal the whole. Now, when we talk about midpoint, we would take that same segment AC, but instead of B just being anywhere along the segment, B would have to be exactly in the middle. And to mark segments in geometry, you do this little tick mark here. You probably have seen it in middle school, but if not, that's how we mark the two segments are congruent. And then if you had another pair of segments in the same problem, you could use two tick marks like that. So if it's 2 and 2, then those two mean that they're congruent to each other. So B is the midpoint here, meaning that both halves are equal to each other. So the midpoint is a point that divides, sorry, that's really messy. That says divides the segment into two equal parts. Still getting used to writing in this program. So sorry if anything is a little messy for you. All right, so let's get started with some examples now. So I'm going to start with number 1. So I'm going to give you that RS. Also, something important to note here is if there is no bar, so there's a difference between saying segment RS versus just RS. RS means it's the length of the segment, so it's 5 inches, 6 inches, whatever. This means the physical segment. And when you read it, you would actually read this as segment RS. When you would say this one, you would just say RS. So whenever there's an equal sign and you're talking about the length of the segment, you should not have the bar over the top of the two letters. So that's going to be square root of 2x. And sorry, I'm also watching my son right now. He's supposed to be napping, so I have the monitor here. So 3 rad 2x, and RT is equal to 64. Now I'm also going to tell you that S is between R and T. I didn't say it's the midpoint of the two, it's just between them. So it could be at any point between R and T. We just know that it is somewhere between them. So let's actually start by drawing a picture here and labeling it. And in geometry, it's super duper important to draw pictures, label. That really helps us to visualize and figure out what the question's asking and how to set it up. So here is S. I just put it anywhere between R and T. It doesn't matter where. I tried to make it so it wasn't the midpoint, just so I don't trick myself into thinking it is. RS I'm going to label, so from R to S, that is the square root of 2x. From S to T, that is 3 times the square root of 2x. And then RT, so the length of the entire thing, is 64. So in order to solve for x, we're going to use segment addition. Take the sum of the parts and set it equal to the whole. So I could take the square root of 2x plus 3 rad 2x, so RS plus ST equals that entire thing. So equals 64. So that's the new part, that's the geometry part, is setting up sum of the parts equals the whole. Now it's just a review from algebra. So if we take our radicals, since they have the exact same thing underneath the radicals, they both have a 2x, we can combine them. So this is like saying 1 rad 2x plus 3 rad 2x. So altogether we have 4 rad 2x equals 64. Whenever you're solving a radical, you always want to isolate that radical first. So you're going to divide both sides by 4. And we get rad 2x is equal to 16. And now to get rid of that radical, since it's being a square root, we want to square both sides. Whenever you square a radical, remember that rad 2x times rad 2x, sorry, that's the doorbell. So rad 2x times rad 2x would give you radical 4x squared. When you multiply 2 times 2, you get 4. X times x is x squared. And we take the square root of that. The square root of 4 is 2. The square root of x squared is x. Now, I don't want you guys to go through this entire process every time you square a radical. You should, at this point, be thinking, anytime I square a radical, I'm just left with whatever's underneath the radical. So if I did rad 5 squared, that just gives me 5. If I do the square root of 3a to the 5th, and I square that, that would give me 3a to the 5th. So when you square a radical, it's always whatever's left underneath the radical. Okay, so now we have rad 2x squared, just going to give us 2x. 16 squared gives us 256. And then we're just going to divide both sides by 2. And we get x equals 128. And this one, oh, I didn't actually end up writing out the question for you. Sorry about that. So if S is between R and T, I wanted you to find RS. So what I'm asking you for, again, here is there's no bar on top, so I'm asking you to find the length of RS because there's no bar on top. Okay, so now we have found X. We want to find RS. So RS was the square root of 2x. So I'm going to sub in my 128 in for x, and that's going to give us the square root of 256, which gives us 16. So RS equals 16. All right, next, number 2. Given, let me give you a little segment here. So we're going to call it N, B, C, and N, we want to find A if NC equals 12, BC equals 4A squared, and NB equals negative 2A. Okay, so we're looking for NB. So let's go ahead and label the picture they gave us. So NC is 12. We know BC, so from B to C is 4A squared, and from N to B is negative 2A. So B again is not the midpoint, so we can't set these two equal to each other because we don't know where B is along the line segment in C. So I'm going to set up an equation. So I'm going to take NB plus BC, which is 4a squared, and set it equal to the whole. So the sum of the parts equals the whole. Now, because this one has an a and this one has an a squared, they're not like terms. Anytime you have an x squared and an x, or in this case, an a squared and an a, you always want to get that equal to 0 so that you can factor it. So I'm going to kind of do two things at once here. I'm going to subtract the 12 over to get it equal to 0. And I'm also going to rearrange this so it's in standard form. So I'm going to put the a squared first. So 4a squared first, then minus 2a, then minus 12 equals 0. So 12 couldn't combine with either of these because it didn't have an a and it didn't have an a squared. So none of those are like terms. So here we are in our standard form, 4a squared minus 2a minus 12. And we want to factor it because we have an a squared and an a. So now we have it equal to 0. I always want to look for a GCF first. So my GCF here is going to be 2. Not everything has an a, so I can only take out a 2. So if I divide each of these by 2, I'm left with 2a squared minus a minus 6 equals 0. So now looking at this, I want to factor that further, but I noticed that it has a 2 in front of the a squared. So since it has a 2 in the front, I want to try and use P's and C's to factor that. So I don't know if you called it P's and C's last year, or however you factored using a coefficient greater than 1 is how you should continue to do it. At the high school, we call it P's and C's. So if you were here, then you should have done it that way. And that's the way I'm going to show you right now, okay, as a review. Okay, so I'm going to do this kind of off to the side here. So 2a squared minus a minus 6. So I'm going to factor that using P's and C's. So the only time you want to use P's and C's is if you have a number in front of your a squared besides 1. So if it's any number other than 1, then use P's and C's if it's factorable. If it's not factorable, then you might have to use quadratic formula. So P is the product of your first and last coefficient. So 2 times negative 6. So that would give me negative 12. My C is my center term. So there's no number here, so that means there's an invisible 1. So my C would be negative 1. So that's your center term, or center coefficient. Okay, so now we want to write it out as 4 terms. So I'm going to take 2a squared, I keep, blank a, and then I keep the last term. So I take out the middle and split it. Some people call this split the middle as the process. So now I want to find 2 numbers to go on these blanks that have a product of negative 12 that combine to negative 1. So if you're a person that has trouble thinking of these, you can always go to your calculator and for your y1 and you put whatever the product is, so negative 12 divided by x, go to your table and it'll list your factors for you. Most of you, I think, can probably come up with your factors of negative 12 on your own. So you're thinking 1 and 12, 2 and 6, or 3 and 4. And which of those, when you add them together, could possibly give you a 1? Now we know the product needs to be negative, so we know they have to have different signs. So you're thinking what 2 numbers would subtract to give me a 1? And so 1 and 12, 1 and 2 and 6 would not, so we're left with 3 and 4. So I know it's going to be 3 and 4. I want them to combine to a negative 1, which means I want my larger number to be negative. So I chose negative 4 and positive 3. Next step is I'm going to group them into 2 sets of parentheses. I'm going to factor out the GCF from each. So I'm taking out a 2a from the first set, leaving me with a minus 2. And here I'm taking out a positive 3, leaving me with a minus 2. Sorry, I have the summer. I mean, I'm talking, but not talking this much. So my throat is getting a little scratchy from all the talking. So now I want to make sure that inside my parentheses, they're exactly the same. And they're both a minus 2, so that's good news. They're the same. So now I'm going to factor that out. So I'm only going to write that one once. And then in my second set of parentheses is going to be what's left over. So essentially what you're doing is you're factoring out this a minus 2, leaving you with 2a plus 3 over here. So I don't know why all of a sudden I had thrown on that equal 0. We were just kind of doing it off to the side. So we don't need that right there. So now I'm going to go back to this problem. So this was just kind of a side note over here. And don't forget to bring down your 2. And then I'm going to write my 2 factors. So a minus 2 and 2a plus 3. Now here's where we've set that all equal to 0. All right, so now we've factored it as far as we can go. We're now, and since there's an equal sign, it's equal to 0, we know we need to factor this. So I'm going to draw my lines and set each equal to 0. So 2 can never equal 0. So, I mean, you can write this if you want, or you can just leave it. You do need to show that you're setting each factor equal to 0. That's really important. And then you're solving for a. So a equals 2 here. Here we're going to subtract over our 3 and then divide by 2. So we get negative 3 over 2. And I'm not going to box it quite yet. Negative 3 over 2 and positive 2. The reason I don't want to box it yet is because I want to go back and look at the problem to see that both of those are going to work. Because where in algebra, most of the time when you were doing this factoring, it was just because you were factoring the problem or it asked you to. But now we're going to, we're actually using it for lengths of segments. So we have to make sure that when we substitute in our new values, that none of our segment lengths become negative because our length has to be positive. So if I go back to our original right here, if I sub in my 2, I got a equals 2. If I sub in 2 in for a right here, that would give me a negative 4 for the length, and I don't want negative values. So that already tells me I have to reject the 2. So let's check the other one. If they both don't work, it means you have no solution. This one is a negative 3 over 2. So if I sub in negative 3 over 2 in here, then I will get a positive because negative times a negative is a positive. So that'll work. And the 2's would cancel, so it'd be positive 3. And then here, if I sub in negative 3 over 2 and I square that, when I square a negative, it becomes positive. So that would also be positive. So I'm actually going to, and this is opposite of what a lot of you guys tend to think, is you always think you reject the negative, but it doesn't always work that way. You're rejecting which one gives you a negative length. So in this case, the positive gives you a negative. So we're going to cross it off and write reject, and you should do both of those things, cross it and write reject. And we're going to keep the a equals negative 3 over 2. And in this one, the direction said just to find a, so we don't have to substitute in. And always remember to read those directions and make sure that you do what you are being asked to do. So if it says to just find x, find x. If it says to find the length of the segment, make sure you sub in and find the length of that segment. All right. Next, we're going to do a midpoint one. So that was 2 different problems of segment addition. Now we're going to do midpoint. So A is the midpoint of segment BT. So again, you would read that as segment BT when that line is over the top. Also going to tell you that BA, notice there's no bar on top, so that means that it's the length of BA is equal to 70. AT is equal to y squared minus 2. And I want you to find all possible values for y. So first I want to start by drawing a picture. So A is the midpoint of segment BT. So here's segment BT. If A is the midpoint, we're going to put it right in the middle. We also know now that these two are the same because they told us that A was the midpoint. Now let's label. BA is 70. AT is y squared minus 2. Find all possible values y. So they didn't give me the length of the full segment here, but we don't need it. Because we know A is the midpoint, we know these two are equal, so we'll just set them equal to each other. And then we're going to solve. So I'm going to add 2 over, and I get 72 equals y squared. I want to solve for y, so I want to take the square root of both sides. Now, whenever I take the square root, it is extremely important that you remember your plus or minus. So I get y equals plus or minus, and I want to break this into simplest radical form. And if it doesn't say, you always assume simplest radical form. Do not give me a decimal that your calculator gives you. I want either simplest, I want an exact value if I don't say to round. I say round to the nearest 10th, then go ahead and type it in your calculator. So you want to find the largest perfect square that you can take from 72. If you can't figure that out in your head, go to your y equals, type in 72 divided by x, and take a look in your table and try to look for where's the largest perfect square. So if you do that, if you need to do that, pause, go ahead and do it. If you already know off the top of your head, or if you type some things in your calculator, hopefully you found that 36 and 2 multiply to give you 72. Also really important that the 36 comes first. If you have on your paper 2 and then the 36, cross it off and rewrite the 36 first. I always want the perfect square to be written first. And then we know the square root of 36 is 6, so it's plus or minus 6 rad 2. So are both of these going to work? That's what we need to check. Positive. So we have two answers here. We have y equals positive 6 rad 2, and then we also have y equals negative 6 rad 2. So if I substitute them in for y squared, 6 rad 2 squared, that'll give me a positive. And if I sub in the negative, it will also give me a positive. And we know if we square them, it gives you 72 minus 2, which is 70. So both of these work. So we have two different answers, positive 6 rad 2 and negative 6 rad 2. And they only ask for the possible values of y, so we're done. We don't have to substitute in or anything like that. All right, and number 4. So 4, a little bit different. I want you to solve for x, and I'm going to give you a picture here. So here is segment M, A, Z, E. And I'm going to tell you that AZ has a length of 2, and AE, so from A to E, the length is 2x minus 4. From M to Z, the length is 2x minus 3. And from M all the way to E, so the length of the entire segment is 3x minus 1. So what I'd like you guys to do now is actually pause the video, and I want you to come up with an equation or a way to solve this. And there's multiple ways to do it. I'll go over one of them, but I want you to try to think about first on your own how you could possibly do this. So go ahead and pause right now. All right, so the way I'm going to go over is looking at this whole picture here. And if we look at this part right here, so from A to E, and then I also look at from M to Z right here. If I were to add those two together, would they equal the entire segment, ME? Well, think about if you moved this blue one down and lined it right up at the end of this green one. Would it go just to E? No, it would go past E because they overlap right here at AZ. So this AZ part right here, this is counted in part of the blue, and it's also counted in part of the green. So it's being counted 2 times. We only want it to be counted once. So what we can do is we can say, all right, well, let's take 2x minus 4, add it to 2x minus 3. So we know that's bigger than the whole thing, which is 3x minus 1. How much bigger? Well, it would be 2 units bigger because we're counting the 2 twice. So we want to, so this was the AE plus MZ minus the overlap of 2, and that should equal the entire segment, which is 3x minus 1. Okay. So again, there's multiple ways you could do it. You could also, another way over here is if you look at just this blue area, if you wanted to find the length of ZE, you could take 2x minus, so to find ZE, 2x minus 4, subtract the 2, and that would give you, if we combine our like terms, negative 4 minus 2 would give me 2x minus 6. So then if I know ZE is equal to 2x minus 6, then I could take MZ plus ZE and set it equal to 3x minus 1. So I could take 2x minus 3 plus 2x minus 6 and set that equal to 3x minus 1. So either way you want to solve it is fine. So at this point, you guys should be able to combine your like terms on each side and then combine from one side to the other and solve for x. So if you haven't done that already, go ahead, pause, solve for x, and then come back to find the answer. All right, so you should have gotten that x equals 8 for your final answer. And if you do have any questions on how to solve that by combining your like terms and things like that, please reach out to me and let me know, and I'd be happy to go over that with you as well. All right, and that concludes our notes for today on segment, addition, and midpoint. Again, if you have any questions, please reach out so that we can go over some more stuff together. Really important basic idea that is part of geometry. Okay, so I hope you guys enjoy the rest of your day, and I will see you soon. Pie out.